All right, good afternoon, everyone. Welcome to a very exciting yet bittersweet day. This is the finals day of our Summer Coding Institute, where we hold our finalist presentations and we present our awards. So a brief agenda for today is going to be from 2 to 2:15, we're going to do an introduction to today's event, and we're going to have some very special opening remarks by a professor in the area. Then we're going to have a whole hour of finalist presentations. These are the top 8 teams that we've selected through preliminary judging over the past 2 days. They're going to be presenting their projects and competing for the grand prize, first place and second place awards. And then finally, we're going to transition into our awards ceremony, where we're first going to have a couple of words from our very special sponsors, our guests from those sponsors. And then finally, we're going to get to what everyone has been waiting for and what everyone came for, the awards ceremony. So let's dive right in. Now, before we start the entire event, I thought it would be great if we could visualize some of the accomplishments of our camp, maybe not in terms of qualitative metrics, but quantitative metrics. It's always fun to play around with numbers and see numbers. So here is our AYSI-SCI camp recap. Overall, we made great progress in our curriculum. We gave 13 lectures in the junior division, 14 lectures in the senior division. In the junior division, they ranged from introductory lessons all the way to advanced topics. And the senior division started out from Python, just starting out with a Python crash course. And then we brought the students through a bunch of different machine learning tasks, a bunch of deep learning methods and models and algorithms, those kinds of things. So it's been great. We've learned a lot of things. And through this process, we have accumulated these numbers. We've spent a total of almost 4,800 hours in lectures, 360 hours in office hours. We've uploaded 30 lecture and office hour recordings to YouTube and growing. And in that time, we've had 3,000 views on our YouTube channel and 611 watch hours on lecture recordings simply out of class. So that's incredible dedication from all of you to invest all this time that you could be doing something else that you enjoy, but rather you chose it to spend it with us, and we are grateful for that. These are the homework completion curves for the junior and senior division. We thought it would be kind of interesting. At the very beginning, of course, everything's going well, and then we saw quite remarkable retention across the entire program, and that's especially considering these students have never seen programming before, and the assignments really do get more complicated each time over the next, because at the beginning we're building on fundamentals, and then as we move on, we're building upon those fundamentals, and every lesson depends on the previous one. So very encouraging numbers. Overall, we had 1,013 assignments turned in, and that equates to roughly 150,000 blocks of MIT App Inventor code that was written. So a lot of amazing work. In the senior division, it was a very similar story. We had a couple fewer students in the senior division, but still, the senior division is extremely difficult to kind of get through because, again, every lecture depends on the previous one. And with that comes increasing difficulty. Yet we saw a great number of students who put their best foot forward and turned in these homework assignments on time. In the senior division, we had 749 assignments turned in by all of its students and about 125,000 lines of code written. That's just incredible if you think about it. Over just 1 month, this is just the lecture program assignments. You've written this much code, you've learned so much, and that is starting from pretty much nothing. So just think about that, it's incredible. We are also, apart from the learning aspect, very proud of the student community that you guys have all built. We know it's not easy to measure, the student community, but we chose in this case to take a look at the amount of messages that you send. And at the beginning of the camp, we were actually kind of worried, whether these students would find interest in talking to each other. But we've been so pleased to see that you all not only are able to help each other to debug each other's programs, to suggest alternate approaches, but you also find enjoyment in playing random games like Would You Rather in the general channel. So overall, 14,000 messages in the junior division, 8,000 in the senior, and overall 30,000 messages sent on our Discord server alone. Pretty out of this world. So I guess what I'm trying to say with all of this is just thank you for everything. A camp would be nothing without its students, and it is really you guys that have made everything so special about AYSI-SCI this year. It was our first time running things, and we didn't really know what to expect. And just again, thank you for making our experience great, and we hope that we have made yours equally great. So with that said, I'd like to introduce a very, very special guest, a distinguished scholar in his field, Professor Cheng-Kai Lee, who is a professor of computer science at the University of Texas at Arlington. He is the associate chair of the Department of Computer Science and Engineering, and he is the director of the Innovative Data Intelligence Research Lab. So without further ado, let's welcome Dr. Lee.
Thank you, Kevin. Hi, everyone. It's my, excuse me, great pleasure to speak to you all at this exciting event. Congratulations on finishing your coding classes. You have acquired highly valuable coding skills, critical thinking skills, and problem-solving skills. Most importantly, you were brave in taking on the challenges of learning something non-trivial, especially during this difficult pandemic situation. Therefore, you all should be praised. Congratulations, well done. I started doing coding when I was 10 years old. The exposure to computing at a young age had certainly shaped my life, as apparently I took computer science as my college major and my profession. The programming languages we started at that time are called BASIC and Local, which many of you probably haven't heard of. The computers we used were Laser 310, Apple II, and some machines of which I cannot even recall the name anymore. The point, of course, is not to brag about how old I am, but rather how much I envy all of you. At that time, no coding camps like this one was available. No online tutorials. In fact, most computers were disconnected silos with no networking. And it was long before internet and the web came around. There was no easy access to computers. I only started to have my own computer when I was about to graduate from college. I still remember how I would sneak into my middle school building during the weekends through a couple of fences. One of them was installed on the top floor as a gate. So at the top right corner of that fence, the gap between the fence and the wall was large enough for a teenager to squeeze through. But that side of the wall is over the stairs from the floor down below. So I would have to climb on the fence like a Spider-Man and reach that gap and then climb over. So if I dropped basically 2 floors, I probably would have died because nobody was there in the building in the weekends. Now that I think about it, how irresponsible and daring I was. Once I'm over that fence, I then would go straight into the computer room and use just some mild force to push open the door, which had a loose lock. Till this day, I still don't know how the lock got damaged in the first place and why they didn't fix it. Once the door is open, then I was like in a heaven. I would stay there for a few hours before dark. My parents knew I was there on computers, but they thought that was arranged with the school. So why did I take such a risk to gain access to computers? You might think it's for starting computer science. At that time, we didn't even call it computer science. And I had a little idea about what computers can actually do. They were very limited anyways. Yes, I certainly was doing some coding exercise, but mostly I was just playing games. Kevin, could you please move to the next slide? Yeah, I was mostly just playing some games, just like what many of you enjoy doing. The computing technologies nowadays are much more advanced, of course, and I'm sure all of you have been exposed to what these technologies are capable of, as they are in every corner of our home, our school, and our society. Therefore, you may enjoy using computers in doing many things beyond just gaming, making animations and films, creating a website or a blog for discussing books you read or disseminating messages important to you, building apps for your own businesses, analyzing COVID-19 data, tracking the NEO-WISE comet, analyzing political discussions and social media messages, promoting social justice, analyzing NFL and NBA game records, and so on, you name it. No matter what your passion is, and regardless of whether you will study computer science in college or not, computing technologies can be very helpful to you and a very important lifetime skills to acquire. Computing technologies evolve very fast. The web, app, and the cloud technologies you learned today may become obsolete sooner than you think. At some point, some other programming language will replace Python as the most popular one. But there's no reason to panic. What's most important is you have learned the way of computational thinking, and you have learned how to gain true insights from data. Maybe let me just give you one example. Kevin, next slide, please. Yeah, so during World War II, researchers at the Center for Naval Analysis faced a critical problem. Many bombers were getting shot down, on runs over Germany. The naval researchers knew they needed hard data to solve this problem. So after each mission, the bullet holes and the damage from each bomber was painstakingly reviewed and recorded. The researchers pulled over the data looking for vulnerabilities. The data began to show a clear pattern. Most of the damage was to the wings and the body of the plane. The solution to their problem was clear. Increase the armor on the plane's wings and the body. So that's very intuitive if you think about it. However, there was a huge problem. And this approach and this decision to put armor on the wings was completely wrong. Why is that? Let me give you just 10 seconds to think about it. And then Kevin, please move to the next slide after 10 seconds.
Feel free to throw your predictions in the chat.
I see many interesting responses. The problem is the analysis didn't consider planes that were shot down, right? The fact that these planes came back means they actually were strong enough to not get shot down, right? And those that didn't survive actually got shot at cockpit, engine, and other parts of the plane, right? So those are actually the most vulnerable areas, but those researchers, they didn't get to see those bullet holes because they didn't come back. And this is very interesting counterintuitive phenomenon. It's called the data sampling bias. Right? This is just one example of the things that you can learn with regard to how to gain true insights from data. And you probably have touched upon some of these in this coding camp. With all the different learning resources available, including coding camps like this, you can indeed effectively learn computing technologies and apply the things that you learn in real world. The projects you have accomplished are very good examples. And particularly, I have witnessed the great things Mr. Kevin Mann, the organizer of this coding institute, can accomplish. For the past 2 years, he has been participating in the projects in my research group at the University of Texas at Arlington. And he had made contributions at the level of a PhD student. I'm saying that without any exaggeration. So I'm so glad to see him now sharing his skills and the experience through this coding institute and other activities. I hope you will build upon what you learned from this experience and continue to learn more and make contributions to our society with the help of computing technologies. Again, congratulations to you all.
Thank you, Dr. Lee. And I think this kind of role that you play in the community, where you actively seek to help students who are interested in these kinds of things. It's just wonderful. I have to thank you for being so gracious as to coming here today, of course, but also, of course, mentoring me for the past couple of years. It's been a wonderful journey. So again, thank you so much, Dr. Lee. Feel free to stay around if you're interested in the projects. Feel free to leave if you have other commitments, but why don't we give Dr. Lee a huge thank you in the chat? All right. So now we're going to move on to our next component. We are going to go into our final presentations. Now, you might have noticed we skipped over the raffle. We're going to talk about the raffle at the very end of the presentation, at the end of the meeting, during the award ceremony. So we're gonna first hand it off to Alay here in just a couple of seconds. But before then, I'd just like for all of you to get to know our judges a little bit. So at this point, I'd like to invite all of our judges to turn on their cameras, to unmute, to say a few words about themselves, what they're interested in, to give us a little bit of an introduction. We can go like in the judge order, maybe Fatma first.
Hello, everyone. I'm so happy to be here today, and congratulations, everyone, for all this amazing work. I'm a PhD student at the University of Texas at Arlington. I'm working with Dr. Chen Kaili. Best of luck. Have fun today.
For sure, the most important thing. Thanks, Fatma. Next, why don't we have David kind of introduce himself?
Hi, everybody. Congratulations on being here. I'm very happy to be here and hear all of your projects. I'm a student at Stanford University studying computer science, specializing in artificial intelligence. So yeah, I'm super excited to hear all of you guys, and good luck.
Thanks, David. And then next, last but not least, Eric.
Hello, everyone. My name is Eric. I am currently studying CS and math at Harvard University, getting a concurrent bachelor's and master's. My current interests are in machine learning and programming languages. So congratulations, and I'm excited to see what you've done.
Thanks, Eric. So those are all of our judges. At this point, I'm going to hand it off to Alay, who will introduce all of our contestants, who will give us some ground rules. So go ahead and take it away.
Okay, hopefully everybody can see the screen that's sharing right now. You should say
Perfect.
final. So today we have our finalist presentations. There's 8 teams that we've chosen over the last 2 days of preliminary judging. Just some last minute reminders for those teams. Each of you guys, your team will have 5 minutes for your core component presentation, followed by a 3-minute Q&A that's led by our judging team, which you've just met. For the actual core component presentation, I'll give you guys, I'll say that you have like 30 seconds left when you have 30 seconds left, so that you know to wrap things up or get to your demo and do what's important, because at 5 minutes, I'll cut you off and it'll go immediately to the judging section. And then at 3 minutes after the judging section, I'll cut off questions again. So make sure you make the best use of your time, because timing is really strict here. When your team is called, the team captain needs to request remote control, and you can do that by clicking up where it says you are viewing AYSI officer's screen. You click view options, and then down in there would be request remote control. I'll grant you remote control, and then you would be able to click through the slides at your own pace. And then for all the audience members, please stay muted the whole time and just be courteous towards our finalists. Let's listen towards each of those presentations, because they've worked over the past 4 weeks for them. But all of you, remember to stay till the end, where we're going to have our award ceremony. And like Kevin said, we're going to talk about the raffles, as well as our future AYSI plans for the main school year. So without further ado, we will get started. So the first team is J18, an app that aids to detect plagiarism.
Hi, my name is AYSI-SCI, and I made an app that aids to detect with plagiarism. According to a study by Donald McCabe, 70,000 high school students were surveyed from numerous schools in America. According to the study, 95% admitted to cheating somehow, and from that, over 58% have said they plagiarized content in some way. As of right now, there's not a reliable, effective, cost-efficient way for identifying plagiarism, and a lot of times it goes unnoticed. Many students are also not familiar with the consequences involved with plagiarizing. The goal is to create a cost-effective and user-friendly app that helps identify plagiarism with a simple push of a button, as well as provides the word and character count. The materials needed for this project was an API key from accredited source, Python, Heroku, and GitHub, as well as my API URL that I built. The first thing I had to do was find an API key from a reliable source. After 10 or 15 options, I picked prepostSEO.com's reliable API key. Then I wrote the code on Python. The reason I had to write my code on Python was because the API key only sent the request in post, while MIT App Inventor was only familiar with get. So I had to make an intermediate API. After I made my intermediate API in the code, I deployed that code onto Heroku, made a few adjustments, and then built the URL. I used the URL and then began programming in MIT App Inventor. I created the designer screen of the app, and then I created the logic for the word and character count. This is the Python code I used to create my intermediate API. And as you guys can see, I have the API key, the API data, and then the endpoint all hard-coded on here. So pre-post API accepts only a post request with parameters in the form. However, MIT App Inventor cannot do a post request with parameters in the form. MIT App Inventor can make a GET call with parameters in the query. So to solve this problem, I created an intermediate API with Python, which can accept from MIT App Inventor and then turn that around and then make a post call to pre-post API, which pre-post API can accept. This is the designer screen and the code of my project. And here I have two examples. In one example, I copied and pasted a text from Wikipedia and the plagiarism percentage came to 100. In the other text, I have a unique sentence and the plagiarism percentage came to 0. That's the word, sentence, character, average sentence length.
Your demo's on that screen.
Okay. And then this is, so first thing I did was I inputted a text from Wikipedia. I checked this for plagiarism. It came to 100. Then I went to the word processor and then inputted that same text and checked for the word, sentence count, average sentence length, and character count. I went back to my first screen, and then I have a unique sentence that I just created up, and I checked this for plagiarism. For this, the plagiarism percentage came to 0. I checked both plagiarism checkers 20 times, and an average plagiarism checker accuracy rate resulted around 65%, while my plagiarism checker's accuracy rate was around 95%. And an average plagiarism checkers, it could only detect direct plagiarism, while this one could also detect if the sentence was reversed or synonyms were used, which is what most students tend to do. And then this is data analysis. Conclusion. This app is effective because it not only detects direct plagiarism, but also when some of the words are changed or the sentence is reversed. During testing, I tested my app with multiple different websites and it consistently provided accurate results. This app will lessen the impact that plagiarism causes, like copyright and ethical issues, and provide a user-friendly experience to the users to detect plagiarism. A few observations were made on how to possibly improve the project. There could be a feature that could identify exactly which sentence was plagiarized so teachers know. There could also be a feature where you can see what source it was plagiarized from, as well as identify plagiarism in books and journal entries as well. This app, however, has numerous implementations and benefits in the future and could help the user identify further academic dishonesty. Thank you so much. I hope you guys enjoyed my presentation. Thank you for your time.
Okay, so we'll start off the 3-minute questioning period now.
Hi, yeah, Ayushi. First of all, I think this is a brilliant project, and it's definitely something that's very applicable today. And I can see your passion in doing this project, and I think that's absolutely terrific. So I have one question with, when you're quantifying the accuracy of your plagiarism checker versus these existing plagiarism checkers. So is your app sort of natively detecting and figuring out this kind of novel plagiarism method detection, or is it kind of, or is it this pre-post SEO that's sort of doing the plagiarism checking for you?
No, so basically the API that I used, it was had a database, so my app can refer it to, and then that app, if you put that URL on a browser, it will also detect the plagiarism. So yeah.
Okay, cool.
Hi. Yeah, I think it's wonderful that you made this. Like making an app to detect plagiarism is awesome. I think that like, especially in terms of the tech scene or the startup scene, like there's so many inefficiencies that can be solved just by like creating better user interfaces to interface with, I guess, APIs like the one you're using here. So that's great. So my question is, like, how do you think you're going to extend this in the future to make it easier for people to use?
Well, I really want people to use this because in many situations in school, people have, I know people who have plagiarized and it was never found out that they plagiarized. So I really do want people to actually use this in the future. And I think that it could actually help people. Like as of right now, I don't have any ideas of how to actually make it useful to the real world, but I would really like to try.
Yeah, so like, let's say I'm checking for plagiarism and like, let's say I'm a teacher and I'm running like an online class and people submit essays to me. How do I get them to your app?
So what you would do is the essay, you would just copy and paste it and then post it on, put it on the text box and then just detect that for plagiarism.
Yeah, sounds interesting. I mean, I guess like versus something like turnedin.com, right, where you can just have a one-click sign in, like it might be worth considering in the future if you want to spend more time on this app, like how to make it easier.
Yeah, we have about 30 seconds left if there wants to be a short question.
I also have a short question. Does your application has any length limitation?
So it doesn't have a length limitation. I tested it on a 600 word essay that I just wrote and it came out accurate for that. So that's like the most I've tested out. So I don't think it has any length limitation for the text.
Thank you.
Okay, great. Good job. We'll be moving on to our next presentation now.
Thank you.
Team J24, the COVID-19 clinic app. So whoever is the team captain, before you start, request remote control. Okay, good. Okay, you can start in 3, 2, 1.
Hello, today we are going to be presenting our app called the COVID-19 Clinic app. My name is Kara.
And my name is Ellen.
These are a table of contents which includes an introduction, research in progress, results and demo, conclusions, and finally, future plans.
So, introduction. In the midst of this worldwide pandemic, many hospitals are becoming more and more overcrowded as a result of COVID-19. And this endangers the lives of many different people, as people don't know what the current state of the hospitals are in, and this may result in them not receiving the medical attention they need on time. The statistics on the right show the severity of the situation. So our solution was to create an app called the COVID-19 Clinic app, which would provide users with hospital locations, as well as their statistics on their amount of resources available, such as the number of available ICU beds. So our app would be able to save time, save lives, and educate people on the current state of hospitals.
Research in progress.
So the materials we used to build this app were MIT App Inventor, a digital map, hospital API, Wi-Fi, location sensor, a Redmi Note 5, and an Android emulator.
Our application utilized a software development lifecycle, also known as CDLC. It included planning, design, implementation, and finally testing. On our planning stage, we had several constraints. The user must have access to Wi-Fi or internet in order for the app to work, and the data must be displayed quickly. Several features we had: a map and markers, where the markers appear on the the hospital's location on the map, and the urgent feature, which gets an instant direction to a nearby hospital and displaying comprehensive data from the API.
So for our design, our application consisted of two screens, the starting screen and the main screen. So as you can see with the flowchart on the right, this is what happens when the user presses the start button. When the user presses the start button, the list of states, counties, and hospitals will appear in their respective spinners. And when the user selects a hospital, that hospital's map location as well as their data will appear below. And this is what happens when the user presses the urgent button. When the user presses the urgent button, the app uses the location sensor to display the user's current location, and then displays the top five hospitals to visit in the hospital spinner, as well as their map location and their data. So for implementation, as you can see in the upper right corner, this block of code is what we use to translate our API into a dictionary, which we extracted data from. We took the geometric data, which were the latitude and longitude coordinates from the API, and used it to code our map. And at the very end, we took these two codes and combined them into a single one.
The hospital spinner will only display the top hospitals to visit based on an assigned score. The score is calculated using the hospital's distance from the user's location, the number of utilized beds, and the total number of hospital beds. The code on the right shows the code we had for calculating the score. For the testing, unit testing was performed to fix errors early on. We tested the map code, stateless retrieval code, county code, and etc. After everything was completed, we integrated everything into one and tested if the markers would appear on the map when the hospital is selected. These are the tests we did. So we did opening screen initialization, main screen initialization, if the state, county, and hospitals would appear in their respective spinners, and if the markers would show up on the map, and if the hospital statistics would be displayed. And all of these would turn out as positive.
So results and demo. By the final step of our testing stage, our app was able to retrieve the appropriate hospital data in every single test, which will be shown in the demo.
Here's the demo. This is our opening screen, so once you click to begin, it will open up the main screen. Upon pressing start, it will retrieve the state list, which will appear in the state spinner. After choosing your county, it will get the county list, which will be displayed in the county spinner. And after that, you're all set to click Find Hospitals. Upon pressing Find Hospitals, the hospital spinner will show you the most recommended hospitals to visit. When pressing Show Details, a red marker will appear on your hospital's location and the hospital statistics will be displayed below. We also have an urgent button feature which automatically finds the user's address and finds nearby hospitals as well as display the hospital's data below.
So conclusions. Our final conclusion was that our app was a success. With this app functioning, many people's lives can be saved as valuable time is not wasted waiting for available equipment or finding a different hospital. Some errors in our app include that this API is not updated daily, so there may be some outdated info at times.
Future plans. An idea we have to improve our app is improvement to the urgent feature. So when it is clicked, the hospital is notified that a new patient is coming. This is so that the hospital can quickly prepare to care for the patient and possibly save the life of said patient.
So thank you so much for listening. Do you have any questions?
Okay, we'll start the 3-minute questioning period now.
Hi, Ellen and Kara. Yeah, phenomenal job. I think this is definitely something that is so timely and apt in today's world that it's fantastic that you guys are working on something like this. So in your future work, are you considering maybe integrating some way you can get live information from hospitals to see, if the peak capacity of hospital beds is passed, or if you can see what the capacity is at for a different hospital?
Yeah, I believe that can definitely be a possibility. Like if we can find some way to get the information from the hospitals themselves and have them like incorporate it into our own app, that would definitely be great.
Cool.
Yeah, like what David said, I think this is wonderful. I mean, if you could get this to include live already this is really great, but if you could get this to include live information and then deal with all the legal issues around that, HIPAA, then I'm sure this could be a really enterprise class app, right? Actually, it would be better than the current hospital apps, which honestly kind of suck. But so I guess my question is what inspired you to take this kind of approach to looking at hospital bed utilization?
So in this time, a lot of hospitals are being filled up because of Corona or COVID. And so like people might not be able to get the help they needed in time. So like when number of hospital beds are utilized, it's like how full the hospital is. So if a hospital is too busy, then the person can't really find like quick help in that said hospital.
Sure. Yeah, that sounds like a really good purpose. I mean, great job. Yeah.
About a minute left if anyone wants to ask another question.
Okay, I guess I'll go again then. So like, what do you think was the main technical feat that you achieved? Because I saw like in your app, you have like a bunch of moving parts, right? Which of these was the hardest to get right?
So I think the hardest to get right was getting as it was retrieving the data from the API, which like because it was a long dictionary, you have to find the correct keys and then like find like the different like key values and stuff like that. So it was really difficult to like find the correct keys for each information.
And it was more about like recognizing the API data format and like how to properly access the different values we had to display from the API. So that was pretty hard to achieve.
And do you think this API could have been better explained? So this isn't on your end, but like, do you think the API that you used, like, do you think they could have had better documentation for this?
I think it could have been like more updated since like it's not updated like it was only updated every couple of days. So it's the information may not be like very recent.
Yeah, that makes a lot of sense.
Okay, that's time. Great job to this team. We'll move on to the next team now, but amazing job for the first two presentations so far. Okay, next team, J26. Request remote control when you're ready.
Could I flip through my slideshow really fast? I did a couple of edits.
Oh yeah, sure.
Alay, there seems to be an update on slide 58. If you want to, you can hit escape and then hit update on that slide.
Okay, yeah, I can update it. Okay.
Yeah, Ishan, if that's what you're talking about, the test plan slide has
Yeah.
an update. Yeah.
Yeah.
Okay.
All right.
Okay, you can start in 3, 2, 1, go ahead.
Hello, my name is Ishan Jolly, and the app that I created is called MediLinked, which is a smartphone application to improve medication adherence by creating an emotional connection. So let's look at the problem. First, a person doesn't take their medication, and as they progress, this turns into a habit, and they begin to forget or refuse their medication more often. As a result, their illness gets even worse, and their doctor prescribes more medication. This process repeats until hospitalization. Let's look at how big this problem is. Studies have shown that 55% of elderly patients don't take their medications as prescribed. Up to 10% of all hospitalizations, which lead to $300 billion in avoidable costs and result in 125,000 deaths annually, are because people don't remember to take their medications. Because so many older people are non-adherent to their medication regimen, creating an emotional connection by using voice and video recordings would not only motivate them to take their medicine, but also create a stronger bond between the grandparent and grandchild. My engineering goals were to create an app that was easy to navigate, to create an emotional connection to motivate them to take their medication, and to reduce forgetfulness through innovative voice and video medication reminder features. Let's look at how my app works. So in the beginning, we are shown a welcome screen, and I just clicked add a medication. And now I'm going to select to take a video recording. This would be the grandchild reminding their grandparent to take their medication. And now I am just going to input information for the specific date and time that I would like this reminder to go off. Next, I will input the name of the medication. So now we can see all of the information I inputted in the previous screen. My video is popping up, and it has come up at the time that I specified. I click reset all, and yeah, that's basically how my app works. So to store all of these voice and video recordings, I use the tinydb.storeValue function, which will store the inputted value into a special storage system. And I can call these values anytime I want to by using the tinydb.getValue function. To test my app, I first tested this app on myself and noted that there were no bugs. And due to the time constraint, I have not finished the second phase of my testing, which is I'm going to have a control group and an experiment group. The control group will just use a normal reminder app on their smartphone, and the experiment group will use MediLink. And I will run this for a month, and I will compare the control group to the experiment group. And my hypothesis is that the experiment group will not only have a higher adherence, but a more enjoyable experience than the control group. I compared MediLink to two other smartphone solutions, Mango Health and MedMinder. I found that MediLink was the best out of all of them. The main difference between MediLink and Mango Health and MedMinder is that MediLink creates an emotional connection, and this really helps to motivate the user. Mango Health only uses a point system, and MedMinder doesn't have any sort of motivation. In the future, I would like to develop my app in Swift, as it will be available to iOS users, and this can also allow me to set reminders for multiple days later, which is unfortunately not possible in MIT App Inventor, as the clock stops working when the device turns off. I would also like to have a refill medication feature, which can contact your pharmacy when you only have a few days worth of medication left. In conclusion, my project was a success as I met all of my engineering goals, and I am sure that MediLink will create many more years of bonding. Do you have any questions for me?
Okay, we can start questioning period now.
Hi, Ishan. Yeah, I love the idea, and I love the design. I love the graphics. You got a nice pitch deck going on here, so I think that's great. What do you think are some of the biggest challenges that you faced when building MediLink, and how did you overcome these challenges?
The biggest challenge was definitely using the clock functionality, as to use the clock functionality, you basically have to pull the value that the user inputs, and you have to convert that into milliseconds. And then you have to store that value into the tinydb, and then you have to, at the perfect time, you have to call the video recording that they've taken, and you need to play that as soon as the time goes off.
Got it. Okay, yeah, that's cool that you're able to figure that out. So awesome.
This is a very useful app, and I hope that you can further improve it and we can later see that in action. I mean, people can download it and use it. My question is, how did you get interested building this app?
Well, this idea was kind of sparked in a tribute to my grandfather. He had to take almost over 40 medications a day as he had Parkinson's. And as he progressed later into his stages of Parkinson's, he became stubborn and he refused to take his medications. So one day, my mom told me to go tell him to take his medications because he wasn't even taking his medications from his caretaker or my mom and dad. And he agreed to take the medications when I told him to. And so that's kind of how this idea sparked, because I knew that he made an emotional connection between taking medications and me reminding him to take his medications.
Hey, I love the app. I guess one question I had when you were developing the app is, what do you think is the most important like psychological effects that your app has on people?
Well, definitely, there's multiple papers on this. It's mainly about how emotional connections, like they kind of motivate people, because it makes people feel as though someone else is looking out for them and they need to do this, and it motivates them a lot more than just a normal text reminder that take your pills. That's taking a video, seeing someone tell you something, it's definitely a lot better than just the plain boring text. And that's kind of what I implemented into my app.
Okay, that's time. Really good job to that last team, ManyLink. Next team is J37, House Stability Detector. So let me just make sure I have everything ready. Okay, and you can start in 3, 2, 1.
Wait, so I saw you request the screen, but I don't have remote control.
You do have remote control.
Wait. Oh, Andrew, wait, but I'm the team leader. Wait, okay. Wait, so can I go now? Okay, I'll just go.
Yeah, go ahead.
Hey. Today we are presenting our house stability detection app created by Donovan, Andrew, and Kevin. Our problem: from 2011 to 2020, nearly 500 people alone were killed from structural collapses of residential buildings. Most of these collapses stem from an unstable foundation, which usually results from the ground being too dry or too saturated. Go, Andrew. Move, Andrew.
I couldn't unmute myself.
Uh-oh, technical difficulty. Can you move? Can you press the arrow button? Yeah, Andrew, how come you have the remote control?
Why does Andrew have control? Because Donovan was.
I should have the remote control. I'm the team leader.
Oh well, keep on going.
Right. All right. Hey, our motivation: to stop the needless loss of property and life from the structural failures of housing units stemming from their foundation. So the chain of units events from an unstable foundation. First, to start off, the foundation gets too dry or saturated. No way for residents to identify those problems. And the foundation gets weaker and more unsteady until it eventually collapses and damages property and has potential to injure or even kill many people. Our solution is the app. Our app detects moisture in the soil surrounding the foundation using a moisture sensor and analyzes it to determine if the foundation is firm and stable enough for your house. Our app will also give you advice on what to do if it detects an abnormal amount of moisture in the soil by directly emailing you. Our app combines accurate and efficient detection with direct alert and context, and that gets us the faster response time and reduced damage to your house. So for our development criteria, number 1, our app had to be robust. Number 2, it had to have a fast response time. Number 3, it had to have an user-friendly interface. And number 4, it had to have an accurate moisture measurement.
So some alternatives to our app are that you could hire experts annually, but that's expensive and time consuming. Or you can try and DIY it, but that's risky, takes a long time to learn, and you have to buy and store your own materials. None of these downsides come with our app, however. Our initial prototype was very similar to that of our finished product, the only difference being that the Arduino board was different than the one that we used in our finished product. The rest of the hardware and software remained largely the same. Our software development lifecycle starts off by us brainstorming, constructing a prototype, building a final prototype, building a final product based on that prototype, where we test it in the field and discuss and implement our results. Implementation. Our app works by detecting moisture levels in the soil surrounding and creating your foundation, and analyzes it to determine its structural integrity. It then recommends different options based on your foundation severity.
This is the design of our app. The first main screen has 4 main components that will take you to 4 different screens. The first screen would be the manual, and it will tell you everything you need to know to connect the Bluetooth to the App Inventor. The second screen is a connection screen that would get the results from the moisture sensor, and it will implement it into the moisture screen. The fourth screen would be the email screen, in which you enter your email information, and the fifth screen is the alert screen that will send you the email. The results screen will get the moisture level and will tell you what you need to do at that certain point, and which will also help send the emails.
So here's the analysis of the accuracy of our moisture sensor and our email API response time. All right, so we found out that the moisture sensor had an average accuracy rate of 97%, was 44 hours, 45 trials effective, and the average email speed of our email API was 24 seconds, and we tested that 15 times.
So all our criteria for this app was met, and it was robust, fast, user-friendly, and accurate.
These are the shortcomings and the problems that we had to solve. If the weather changed rapidly, then the results would be varied. So if it had just rained, then the moisture sensor would get results that would be very not what you would expect. So the solution would be getting results over a period of time and then averaging it like a week or a month. And averaging more values would get more accurate results. Other applications. You can also use this app to detect moisture in walls, floors, or ceilings, or it can just double as a general moisture sensor for planting crops. And there are way more possible applications for our app.
And here's our demo video.
What? Hey, what?
Good for it.
The manual will tell you everything you need to know from page 1 to page 8 to connect the Bluetooth to the Arduino, and the alert will send alert emails to the user.
The rest of it was basically just showing how the email sends. And
Okay, we'll start our 3-minute questioning period whenever the judges are ready. So.
So my question is, how are you going to distribute this app to people? By the way, I love the user interface of the app, so props to that. It's very creative.
Andrew. Yeah, it's your turn.
Wait, what? Oh, okay. Wait,
Yeah.
what was the question? Like, my internet was a bit unstable.
Sure, I can repeat it. Yeah, so how are you going to distribute this to people? So since I noticed you're using like a special Arduino with certain like moisture detector for this, so like, I guess like thinking into the future, like if you want to put this into production, like how would you get people to use this?
Well, because we can't publish this to the MIT App Inventor because we have many different extensions, in the manual of our app, it can tell people about what to do when they buy the Arduino and how to actually wire it to get it to connect to the MIT App Inventor. And we'll also provide a link for a code so they can copy and paste everything into the MIT App Inventor themselves and make the app themselves.
Yeah, okay, sounds good. Very DIY solution.
And the app itself only costs $30 for all the wiring, all the boarding, and it's very cheap, and it's a one-time cost, and it'll work as long as your MIT App Inventor is supported.
Got it, that makes sense.
Yeah, this is a great idea. And as Eric said, I like the user interface as well. It's got great graphics. And I also like the 8-page manual. So you guys used an Arduino. How did you guys connect the wireless embedded system to your MIT app?
Well, we had an extension called Bluetooth Low Energy or Bluetooth LE. And because it's Arduino, it's different from other Bluetooth connectors. So using the settings, that will not work. And so we used the Bluetooth LE and we connected it to MIT App Inventor. So we used that extension to be able to communicate to the Bluetooth module.
Wow, very, very cool.
Yeah, it seems it's a very cool work. I hope you guys had fun while building it. Did you face any challenges while measuring the soil moisture?
Well, there was a few challenges because I had to go through different codes on Arduino app that I installed on my computer, and I wrote Java code on there because there were different, I guess, holes in the boards. So when I tried to code it on there, it wouldn't respond. And so that was the main challenge. And another challenge that I had to overcome was learning that the circuit board was actually low energy Bluetooth, and I spent 5 days literally trying to connect it to normal Bluetooth. And so I finally learned that it was low energy.
We learned a lot from creating this.
That's time.
Thank
Great
you,
job, guys. That concludes all of our junior division projects, our 4 junior division finalists. And we'll start up with the senior division finalists in just a second.
Yeah, we're going to take a brief intermission for the judges. If you guys need to go get anything, do whatever you need to do. And once you're back, just check in with us, and then Nalay will help us proceed with the next.
And the first senior division project will be Team S1, the alert system for reducing occurrences of car accidents. So just be ready to present when we get back in around 2 to 3 minutes. Okay, welcome back, everybody. We'll get started with our senior division presentations now. We have 4 senior division finalists. First team is team S1. And let me get my timer ready, but you should be able to start in. Feel free to start in 3, 2, 1. Go ahead.
Hi, my name is Kyle. You all can hear me, right?
Yes.
Okay.
We're
Grace,
missing one of our members.
Okay, and then we can.
Sorry, I'm
Okay.
Go ahead. I can restart.
Yeah.
Okay,
Yes.
cool. All right, so I'm Kyle.
I'm Grace.
And I'm Eddie.
So our project was focused on developing an alert system for reducing driver-induced motor accidents. So this idea was inspired by the fact that a lot of careless mistakes that drivers make on the road are actually the cause of a large majority of car accidents. So I know that most drivers have probably made these mistakes at least a few times, but the second it becomes a bad habit, that's when things turn extremely dangerous. So to solve this problem, we wanted to develop an alert system that could reinforce safer driving habits, such as following regulations at stop signs, avoiding drowsy driving, and also avoiding braking or accelerating too quickly. So in addition, it must be low cost, easy to implement, and also generalizable to other users. So here's a quick overview of what we'll be going over in the next few minutes, and here I'll pass it off to Kyle.
Great, thank you. So the data and features we need for our program are speed diagnostics from the car, pictures of road signs, and facial features. So we go about this by using USB webcams and something called an OBD sensor. The sensor via Bluetooth returns car diagnostics, and all of these inputs together, we process in our main computer right here to output audio warnings.
So this is our drowsiness detection process. Since our webcams are directly connected to the application, we can grab the live feed and perform feature extraction while the program is running. And given our video input, OpenFace uses the point distribution model to extract facial landmarks, head pose, and eye gaze, and aligns the face image with a mask to create a visual descriptor which is needed to gauge action unit presence and intensity. Once these features are pre-processed and then normalized, the program is outputted a CSV file containing these facial action units. This data is then fed into our model to give the user their current drowsiness rating. So next we have our harsh acceleration detection process. The acceleration is first calculated by using this equation, using the data received by the OBD. And then using logic statements, the user is given feedback based on whether they were driving past our set acceleration thresholds, which were determined through extensive research.
Lastly, once a user approaches a stop sign, the single shot detector we're using, YOLO, will detect and then warn that, hey, there's a stop sign right here. So what this will do is it'll then prompt our program to check the CSV files of the gaze vectors and see whether or not the person has looked left and right. And so we'll use the OBD sensor to see if the person also came to a full stop or not. And this will alert the driver about if they made a mistake or not.
So to recap everything that we've discussed so far, here are all 3 processes mapped into one flowchart. So as you can see on the very left side, we have our initial input, and then on the right, we have our desired output with the speaker. So as you can tell from all the arrows, everything's extremely interconnected, and you can tell that everything's communicating and working with each other.
Great, so here are our quantitative results. The diagrams on the right show our training phase, where we were able to minimize the loss in our models without greatly overfitting. The statistics shown on the left are when we actually tested our program. With approximately 30 supports each, all subtasks exhibit both a relatively high precision and recall. The 2 values are also summarized in the equally impressive F1 score, the harmonic mean of the 2. So these numbers highlight, of course, the great performance of our program. And so we have a demo here showing how exactly our program works with real-life application. I'm going to accelerate and brake really harshly and see if the system throws us any warnings.
You're accelerating too fast. You could damage your drivetrain components.
Okay, so now braking.
Your braking is too harsh. You could damage your brake pads. You are heavily drowsy. Stop sign identified ahead.
Alright, so as the system has just notified me, we're approaching a stop sign, and for this trial run, I'm only going to look to the right, and I'm also going to not fully stop while Kyle looks to the left for me.
You did not look left.
And as you guys can
You did
hear,
not fully stop.
the system said that I didn't look to the left, and I also did not fully stop, so that would be something that I would work on in the future.
Okay.
I'm gonna accelerate and brake really
Sorry
and see
for
if
the
this.
audio lag. Anyways.
30 seconds.
Okay, so during our testing phase, we found that there was slightly reduced confidence in feature extraction when the webcams were under insufficient lighting. And a similar problem surfaced in gaze detection, where the gaze detection process was not able to detect looking left and then right in some cases when the driver glanced too quickly due to a low frame rate in the feature extraction. We believe that our proposed application could be beneficial to auto insurance companies, parents of teen drivers, and self-achievers who are looking to better their driving skills. By implementing Flask and better hardware sensors, we could get quicker detection results and alter our program to be even more preventive, further reducing the rate of driver-induced motor accidents.
Okay, that's time.
Thank you.
So judges can get started with their questions now.
Yeah, this is a super impressive project. I love it. In your YOLO V3 network architecture, did you guys decide to transfer learn or fine tune, or is it more of just directly collected data and just trained it?
Yeah, it's transfer learning. We used a GitHub repository to go ahead and install their YOLO model or their pre-trained weights, and then we went ahead and modified them.
Oh, okay. David, do you want to continue? Or?
Oh, no, go ahead. Go ahead.
Okay. Yeah, about that, I have a couple other like follow-ups on that. Like, so what do you mean by modify them?
Okay, well, we didn't modify them directly. Like, obviously, we went ahead and trained them using their .py files. We ran them, and we went ahead and uploaded them on a GPU server, and we used a data set called LISA. It's just a bunch of stop signs. And so specifically right now, our functionality is to mainly identify stop signs out of all the traffic signs, at least for now, right? And so we just went ahead and trained it based off those stop signs. And so that's like how the transfer learning works, right? It's just like the pre-trained weights that they have, and then we built upon them with our own training data.
Thanks. Yeah, that makes perfect sense. So the other thing I wanted to ask was with regards to like prior art. So like, what are prior approaches in the literature that you've researched for solving this problem?
Sorry, what was your question? The first part? I can hear
prior
you.
art. Yeah, what's the prior art on like?
Oh, okay. Yeah, I can answer this one. So definitely current technologies that are in place, things like I've mainly researched up on things like electronic stability control or things like automatic braking, and those things really don't address the part of the problem that we wanted to hit. So we wanted to hit like driver related factors, while those were more like situational based on the condition. Like if there's a slippery road, that's where those can come into play. But we wanted to really address like when drivers are having like bad habits, and that's what's causing a lot of these car accidents.
And to follow up on that, sorry. And And to follow up on that, our drowsiness prediction model is different than most drowsiness prediction models we saw online, which do CNNs. And the reason we used facial action units plugged into a MLP model is because we believe that there are like certain minimal facial patterns that might be overlooked by a spatial detector like a CNN. And by using these action units, which are encoded into a scientifically backed system, the FACS, we believe we can get better accuracy for drowsiness detection. And of course,
Thanks. I would like more comparison on.
Okay, great presentation from Team S1. Next up is Team S7. This is the project titled SUDS, Soap Underwater Detection System. So request remote control.
Sorry.
Okay, great. And you can start in 3, 2, 1. Go ahead.
Good afternoon, everyone. Meet SUDS, the Soap Underwater Detection System. SUDS is a tool which can help your dishwasher save water and electricity.
If you're hoping to save water, when would you stop your dishwasher? When the water looks like sample 1 or sample 2? Currently, dishwashers overrinse dishes which are already clean, and the current solutions attempt to use soil sensors, which detect food and not soap. Can you tell the difference between these two samples? On the left, we have 2 cups of water which look nearly identical to the human eye, representing clean and soapy water respectively. However, clean water and soapy water absorb light differently after physical agitation. With our optical sensor, we can see the jagged contour of the clean water in sharp contrast to the smooth upward trend of soapy water. We will be using AI to recognize these patterns.
We wanted to make this as simple as 1, 2, 3, with our one goal of being able to save water by identifying it from one of 2 classifications, clean and soapy. We utilize a 3-part system: a sensor as an eye, a dataset as a knowledge base, and neural network as the brain. However, after conducting tons of research, we realized that there are no existing datasets for this purpose, so we decided to create it ourselves.
To generate a high-quality dataset, we needed a setup. In our setup picture on the right and simplified diagram on the left, we have 3 key components. The LED light tube passes through the water sample and is received by the IVAR project, a 9-channel optical sensor that measures from 410 nanometers to near infrared. It measures spectral transmission as a function of time, and each sample is a time series consisting of 20 temporal data points. We shook, dropped, and tossed our samples to simulate dishwasher jets and spray arm movements. We also tested combinations of detergent and everyday food, creating a total of 18,000 data points. We took samples of our meals at various stages of the dishwashing cycle. We tried many detergents borrowed from friends, which was a lot of work, but it was very fun. The only downside was my mom being mad with all the dirty dishes we stockpiled in the refrigerator. Moreover, we published all of these data points publicly on our GitHub website and the dataset on Kaggle. Both of these are one of a kind and first of a kind because we personally made them. By making these public, we hope to help other researchers as well as science fair participants.
Now, back to the 2 cups of water from before, let's talk about why the patterns occur. When water shoots out of the jets in the dishwasher and is hit by spray arms, the water is disrupted, causing the clean water's jagged contour. However, soapy water dampens the disruption, leading to a smoother trend. One thing we realized was that different light intensities will affect the neural network's decisions. Now here's where the magic comes in. With our custom rescaling algorithm, we converted the patterns into the 0-1 range, making it easier to extract signatures for each sample.
Here's the rescaling algorithm we created and a zoomed in graph of our rescaled values. The signatures of clean and soapy samples become extremely distinct after rescaling. This ensures that our application can be scaled to other dishwashers with varying light intensities and conditions, as a neural network only detects for these patterns.
Now let's talk about the models. To establish a baseline model, we first implemented a basic 2-layer MLP that analyzed information from the 9 channels for each time step. We were able to get about 65 to 70% accuracy with this model, but we thought we could do better with the information from the time series we discussed. With deep learning and a double-stack LSTM layer, we got an accuracy of 85%. Our key focus was minimizing the misclassified soapy water by tuning the hyperparameters. We wanted to make sure our precision was as high as possible, because we didn't want users accidentally ingesting soap due to an error from our model.
It's not working. I'm clicking. Oh.
After all the hard work of the past few weeks, we were able to deliver on 3, 2, 1. With the 3 components we created, the setup, the dataset, and the neural network, we're able to save significantly on 2 valuable resources of water and electricity. We presented our application to AMS sensors, and they're interested in our future developments. Our one project idea, displayed on the right, is waterproof and Wi-Fi enabled to tell your dishwasher when to stop rinsing. Check back in a few years, and this may just be in your dishwasher. Thank you for your time.
That's time. Great job to this team. We'll start questioning whenever the judges are ready.
Great work. I really like your work. And I have two questions. First, what is the size of your data and how much time did you spend on creating this data set?
Wait, can you repeat the first part of the question?
Sure. What is the size of your data set?
So we used multiple water samples. In fact, we used 10 different soap brands and 10 water samples. And as stated earlier, the sensor gives us a reading on 9 lines of the light intensity, which is 18,000 data points.
As for the second question, we spent roughly like 3 weeks just collecting all of these samples because we had to build a setup that would consistently give us results every time. Developing this setup and also creating all of our samples along with all the detergents and different food types because we wanted to ensure that it would be comprehensive and high quality. So we had to make sure that we left no stone unturned, and that's why it took so long for us to build the data set.
Yeah, so I have a question. So how practical is it to apply this application? So like it's really fascinating the work you're doing. I think this is like a great like new topic. How possible is it to actually deploy this to like edge devices? It sounds like you want to deploy this to like IoT like dishwashers, right? Like is your deep learning approach like compute efficient?
Aaron, do you want to take that question?
Okay.
Yeah, sure. So we'll be putting it in the shell we see on the slide. So mainly the only reason we have the shell is to connect everything together and have it waterproof so that we could insert into dishwashers. And it should be pretty simple. All we have to do is have the light coming out and the water to be able to come in so our sensor can detect it and transmit the results through Wi-Fi to the user.
And Alan, could you flip to the slide in our additional info with the other algorithm? Yeah, so in addition with the neural network, which isn't too computationally expensive, we also implement an algorithm. So this script has to read 3 measurements of clean until it actually stops. So any kind of mistakes that our model would make would be covered up by this, just as it would reduce the probability of a mistake by way further.
Great. Sounds like you've done some extensive like fine tuning after this neural network. That's good.
Okay, that's time. Great job to that team. Okay, the next team is team S22, titled Fast Violence Detection in Videos with Deep Learning. So whoever's team captain, great. And you can start presenting in 3, 2, 1. Go ahead.
So our project is Fast Violence Detection in Videos with Deep Learning by me, Eric, Judah, and Kevin. So the key problem we are trying to address is the clear underreporting of violent crime to police, as only 43% of violent crime is actually reported to law enforcement. However, a large presence in many of these situations is the presence of security cameras. If we are able to capitalize on the capabilities of many of these security cameras with accurate and automatic detection, not only will this lead to a faster response time, but it will also significantly aid in catching the assailant in the first. Next slide. So here's a general overview of a typical violent situation in a violent scenario. And as shown, really all of the endings have either some sort of sizable delay before it actually gets reported to law enforcement, or B, the scenario is not even reported at all. However, with the implementation of our violence detector, this will completely minusculize many of these delays and will even completely get rid of the situation where it's not reported. Next slide.
This is our violence detection algorithms pipeline. A 3-channel RGB image, 299 by 299 pixels, goes through a pre-processing phase and a series of neural networks. It outputs a probability distribution corresponding to its confidence in how violent the image is. Next slide, please. The images are passed through a pre-processing algorithm. The pre-processing algorithm takes the largest contiguous area of motion detected and uses that area as the region of interest. Finally, the crop region of interest is sharpened using a kernel filter, and this allows for the objects and edges in the image to be much more distinct. Next slide. After the image gets pre-processed, it is passed into a series of deep neural networks. First, features of the image are extracted through a pre-trained CNN called Exception. Exception was chosen because of its quick speed and high accuracy in classification. The features are then passed into a LSTM layer, which remembers previous frames to get the context. The result of that is then passed into a dense layer, which condenses the results of the AI into a probability distribution. Dropout layers in between are then used to help the model generalize to inputs it has never seen before.
So when the image is captured, it is first sent to our API in base 64, where a PHP script passes it to a Python script. We use a speed technique in which the Python script is always running and the frames are sent to it in real time. This avoids the lengthy startup time. The script then returns the prediction results to the PHP script, which within seconds sends it back. Next slide. So the graph on the left shows the predictions versus what actually happened, and as you can see, the model did a reasonably good job of detecting violent crime as it happened. And the graph on the right shows violent detection accuracy versus non-violent. Next slide.
Now I'll show a quick 30-second demo. This is a really basic demonstration of how the AI would work in action. The AI has never seen any part of this entire video, yet it can still accurately classify which sections contains violence and which are non-violent. At the top left, you can see the confidence of the algorithm that it is violent, and if the confidence is above 0.5, then the algorithm will classify as violent, as seen right now.
So as you can see, the violent detection accuracy was 60%. And although only 204 out of the 340 frames were diagnosed correctly, 100% of the violent sections had the AI say that it was violent at some point during the section. So if any act of violence is happening, we will be able to figure it out sometime during the act. And like Albert said before, most acts of violence don't get reported. And even if they do, most reports will take too long. Our response is more effective and faster than any sort of human response. And you can see that because our response time is 320 milliseconds, which is as fast as any human reaction. And the nonviolent detection rate is also very accurate. So in the future, using deep learning on data from cameras can be very key. As you can see in the picture, we can use basically the exact same method with deep learning to figure out whether or not someone is carrying a firearm and using the firearm in a dangerous way. This could greatly help the job of security officers, police, etc., and in general, increase overall security. Thanks for listening. Judges, do you have any questions?
I'll start the judging period whenever the judges are ready to ask a question.
Okay. Wow, like I really like your work. This is very it's like a very good application of neural networks, and it's a complicated problem given the video inputs. So I have a couple of questions about your methods. So first of all, I can't tell whether you covered this in the presentation. I'm also looking at your report. Where did you get the data?
We got the data from a data set called it's called the Caviar data set. It contains violent and non-violent videos from different environments.
Okay, and was this mentioned in your reports? But I don't think I see it anywhere. Okay, well, anyway, in terms of leaving that out, it's just remember that you should probably include the data sets that you used in your project. But that's all right, it's just a minor thing. Can you go back to the slide about your network architecture? Yes, so yeah, this one. So my question is why do you have dropout at your final logic layer, like, why are you dropping out your final output predictions?
Okay, so basically we use the final predictions, the final probabilities to like, do like an average over like an interval of 3 seconds. We use those probabilities to classify if it's final or not.
Right. I'm talking about like after your LSTM layer, when you aggregate all of your features over time, like why do you have dropout at the end for your final class labels? Like, is this just a typo on the slide, or can you help me understand if there's something going on?
Yeah, I'm pretty sure that we don't actually have dropout there because then the accuracy would be much lower. So I think that's just.
Okay. Yeah, I'd hope so.
Yeah.
Okay, interesting. Yeah, I mean, it's a good project.
Yeah, I think this is a fantastic project, and video recognition is a hotly studied and pretty difficult problem to solve. So it's cool that you guys are tackling this kind of challenge. Do you foresee any sort of ethical concerns with taking CCTV video or surveillance? Do you foresee any kind of consequence from that standpoint?
Well, we already implement things like CCTV in like everyday life and monitoring like in many public areas right now. So basically, apart from the current security issues, I don't think there will be much of an increase of that because we're simply just implementing that algorithm into these cameras themselves.
Okay, that's time for questioning. Great job to this team. We will move on to the last team. S32. This is Endangered Species Classifier. Yes, the last senior division finalist. So whoever is the team leader, please request remote control. Great. Let's get started whenever you start. Whenever you're ready.
Okay, we'll get started. Are you two ready?
Yeah, I'm ready.
Okay. Hello, I'm Alex, and I'm with Evan and Michael today to present our endangered species classifier. The problem we aim to solve is the extinction crisis. Extinction rates these past few decades have increased rapidly, which is most commonly attributed to human population growth and its after effects. As the total number of unique species decreases, biodiversity is lost and ecosystems degrade, resulting in various social issues and the loss of potential health benefits. Many people are either ignorant to this problem or do not care much for it. This app gives them a more interactive way of learning and to even identify different species by themselves, raising awareness of the problem and producing personal attachment.
I don't have control of the screen anymore.
Oh, cool.
Okay, go ahead.
Can you restart?
I can, sure. Why not?
Good? Okay.
All right.
I'm gonna start again. Hello, I'm Alex and I'm with Evan and Michael today to present our endangered species classifier. The problem we aim to solve is the extinction crisis. Extinction rates these past few decades have increased rapidly, which is most commonly attributed to human population growth and its after effects. As the total number of unique species decreases, biodiversity is lost and ecosystems degrade, resulting in various social issues and the loss of potential health benefits. Many people are either ignorant to this problem or do not care much for it. This app gives them a more interactive way of learning and to even identify different species by themselves, raising awareness of the problem and producing personal attachment. There are current solutions to this problem. However, they have downsides that heavily limit their efficiency. Refuges made to protect wildlife are highly ineffective due to lack of manpower and resources available, allowing them to only encompass a small sum of Earth's various species. The Wildlife Conservation Society's decision tree app, Wildlife Alert, not only takes a lot of effort to use, but is highly susceptible to human error. Our app is not meant to directly protect endangered species, but to promote the conservation of them by raising awareness with the average person. The graph illustrates the increase in number of endangered species, but with the lack of sufficient funding to prevent and recover from species endangerment. With increased awareness among the global community, more funding can be raised by national and international governments and organizations to improve conservation efforts.
The objective of our project was to create an app that can inform users about endangered species by classifying them and demonstrating the ubiquity of endangered species in our communities. Our engineering goals included being able to classify species as well as providing information regarding the habitats and physical characteristics of the animals. We also included features to help improve user experience, such as the encyclopedia and the advanced search, which will be demonstrated later. The main obstacle for our app was the lack of data sets for our specific needs. Right, here's an overview of our workflow. Our process started by creating the model to classify species, after which we started developing and designing the app. We created a custom dataset using a web scraper of Google Images and a database of the rare, threatened, and endangered species in Texas. Using this database, we were able to generate a list of search queries and use Selenium and request libraries to download and to store the images. The model is based on ResNet 50, with one fully connected layer to classify the species themselves. We chose ResNet 50 because of its ability to successfully handle many different classes. Our model ended up achieving a 69.34% top 1 accuracy and a 100% top 3 accuracy. The top 1 accuracy is the percentage of images that are classified correctly as the first choice, and the top 3 accuracy is the percentage of images for which the correct classification is in the top 3 predictions. The use of computer vision makes our app much faster than decision tree style classifiers such as the one employed by the Wildlife Conservation Society.
The app began in 2 ways, animal classification and encyclopedia. We created the encyclopedia as a tool to help users navigate through 636 different species. Then we created the captured image portion with the help of the encyclopedia to give users information on the species they classified. And once the users find a species, they go to a local database that has information for that species. Once we finish the app and we're able to start our testing phase, we used our model on a variety of examples as shown to the right. We also implemented features such as autocompletes, input checks, and help buttons to improve user experience. Let's take a look at the video demo. When opening the app, you have 2 options. You can either take a picture or go to the animal encyclopedia. To search for a species, type in their name, let's say Western sand darter, and click on check species. It'll bring up a new page with habitat description and lots of endangerment status info. The other option is to go to advanced search. Let's say I want all fish and reptiles that are federally and state listed endangered, and it'll bring up a list on the bottom that matches those constraints. To take a picture, go to identify species and click on classify species. In this example, I have an image of a frog. I take the picture, I select it, and then now I need to crop it. Once I press done, the app will return 3 predictions. To the right of each prediction, there is a search button that allows you to pull up their definition page. So we currently have wildlife refuges to protect endangered species, but of course funding will not keep up with the rising rates of endangerment. And since we are creating an app to raise awareness to protect those species in our natural environment, we would like to improve our database as well as expanding scope by adding plants or invasive species, which can also damage the environment. In the end, our app aims to raise awareness for the endangerment of thousands of species and promote conservation efforts among the general public. Judges, we welcome any questions you have.
Whenever the judges are ready to start asking, I can start the timer.
Hi, all. Yeah, great project, great idea. This is definitely a very applicable area. So when you decided to train your neural network, so the data set that you are trying to classify, how many different classes are there total?
So we have 636 different species that we can classify, and we use the web scraper as I mentioned before, and the training data set has roughly 70 images per class, 10 images for the, and then for the validation set has 10 images, and for the testing set has 20 images per class.
I see. Okay. And then in your ResNet architecture, did you just remove the last fully connected layer and replace it with a 600 class fully connected layer for classification output?
Yeah, so we actually did that at first, but it wasn't giving us very good results. So we also unfroze the batch normalization layers to help it, reclassify for our specific needs versus versus the data set it was originally trained on.
Right. Okay. Yeah. Awesome. Yeah. Impressive project.
Great work. I really like how you were very explicit about how you got the sources of your data and all. So a quick question I had was, you mentioned that you're only getting 10 images for each class. How do you deal with this, I guess, sparsity of input data?
Oh, so for the training data, we had 70 images per class. And for the validation data, we had 10 images per class.
Okay. And my other question was, like, you said you got a lot of these images from Google Images. Like, I know personally from experience, if I search something up on Google Images, like, I might get like a completely different animal, right? So how do you handle like this noisy input?
Yeah, so we actually tested it. We actually used the first 70 images that came up on Google because those were the most likely to be the correct image, versus the later images were more likely to be something like a map of where the animal is, or a research paper about the animal, or just a completely different animal. So that was one way. And the second way was we used the scientific name, as that was more likely to yield the actual animal versus something else that had a like a colloquial name that we would have searched instead.
Yeah, sounds good. 100% top 3 accuracy is not easy. Good job.
Okay, that's time. Great job to all of our 8 finalists today. That was an amazing showcase of projects and a great testament to what you've learned over the past 8 weeks of our program. We're really proud to see how everybody's come, not just the 8 finalists, every single person who competed or participated in the program over the past 8 weeks. In a few moments, we'll start the award ceremony, but we do need to figure some things out. But all of you should stay tuned. Stay tuned for this award ceremony and make sure that you stay on for awards, raffles, and future plans. But we'll get back to you in a little bit.
Sure. Thanks so much for the for helping out, Alay. At this point, we're going to start out the award ceremony, but just a note to judges. At this point, you can go ahead and mute yourself on Zoom or briefly leave the call, whatever it may be, and join the senior finals discussion channel, the voice channel on Discord, so you guys can talk about the final rankings. Keep in mind, scores are not the end all be all. Feel free to discuss, shuffle things around. And then once you're done, send a message into the finals chat. And then our officers, namely Derek and Alay, will be there to process the results into our presentation. Any questions? Okay, looks like we will get started. So welcome everyone to the part of the show that everyone was waiting for, the award ceremony. As Alay mentioned, we are proud not just of the 8 finalists, not just of the 30 teams or 30 or so teams that will win awards, but all of the 60 teams that submitted something, because it's really not easy to pick up a completely different skill and nurture your skill and then apply it to something all within 2 months. It's really remarkable what you all have done. With that said, here's a little preview into what we're giving out today. I believe there are about 30 trophies. Each team will get one. First, second, and grand will get double column trophies. And we're also going to be giving out some special awards. Stay tuned for that. Our officers are going to introduce those. But before we dive into the awards themselves, we'd like to invite some very, very special guests from our sponsors of AYSI. Because as you know, without the support of our sponsors, of all the people in the community, this event would not have been possible. And we're grateful for them to provide us with the opportunity to provide all of you this summer experience. We hope you've learned something from them. And at this point, we'd just like to invite them to share a few words. So first up is Mr. Mike Lusk. He is the Executive Vice President of Operations and Supply Chain Management at AMS. And I will allow Mr. Lusk to introduce himself. So without further ado, let's welcome him up.
All right, Kevin, can you hear me?
Loud and clear.
All right, very good. Well, good day to all. As Kevin already indicated, I obviously work for AMS, where I run the global operations teams. It's a real pleasure to join you today. First off, I'd like to say thank you for the invitation to spend a few minutes with you. I think, secondly, I want to congratulate all of you, and especially these final presenters. Very exciting stuff from what I've seen. Great ideas, real problems, you know, thought-provoking approaches, imaginative approaches, and potentially deployable solutions. You know, AMS is in the sensor business, so anything that has to do with structured light or environmental sensing, you know, we have a keen interest in it as we go forward relative to how we see those products materialize in the real world. And so very exciting work. So again, congratulations to all of you. I hope you enjoyed the effort. I hope you had fun. I hope you had a good experience above all, okay? In my lengthy career in the semiconductor industry, I want to make sure you know that it's principally always been about what kind of an experience that you have. And those experiences mean a lot. And those experiences help you find your passion for what you want to do over the long haul. And I've certainly seen a lot of passion today. So thank you very much again. And it's been a pleasure.
Thank you, Mr. Lusk. We really appreciate AMS's support of our organization, and thank you for being here today. And we're glad that you enjoyed the presentations. So next up is going to be Miss Angela Chen. She is the president of the Chinese Association of Science and Technology.
Hi,
so let's
everyone.
Welcome her up. Hi there.
Hi, Kevin. Well, first of all, I want to congratulate you on this amazing summer camp. I just want to say that we're so proud of your organization being able to put this together. I look at today, there's about 180 participants on this virtual call, and those projects who have done, you know, the project that research have done remotely are just as in-depth as the ones that we would have done in our normal summer camp in person. So I was really impressed about what y'all can have achieved. You know, during this pandemic, it's a difficult time, and everybody was trying to figure out a new way to do things and figure out a new way, but a more efficient way to figure things out. And I think you and your organization and everybody who participated in this have just done that. Just a little brief introduction of Chinese Association of Science and Technology. I wanted Kevin to show 2 pictures of the past summer camp we have done to see if you recognize where Kevin is in this past 2 years. So we're very proud of Kevin to be our graduates, and we're very proud to support and sponsor this year's summer camp, given that we cannot do one in person at University of Texas in Dallas this year. So just with that said, I think this is a great inspiration to keep everyone on the call today. Just, you know, there's nothing really can stop you to achieve what you want if you just try hard and be innovative. And this is exactly what everyone has done this summer. Those pictures shows the good old times, and have seen the growth since then, and for everybody to promote, you know, STEM project. So just want to congratulate everybody and you in the success of organization, and I hope we can, in the near future or maybe next year, we can continue to do this, or to do a combination of both for those who can participate, continue to be in this format, and who cannot participate in person, we can do that remotely online. So that will be the perfect scenario in both worlds. But congrats for everyone. And there's a trophy for anybody who identified Kevin on the picture. Just kidding.
Yeah. Yeah. Well, we could, you know, make up a certificate or something. But thank you, Ms. Chen, for joining. If any of you are not aware, CAST-TX is an organization that typically holds summer research camps at UT Dallas and UT Arlington. And so that's actually how I met Dr. Lee, is through this program, and we've been working externally. But it's just a great way to meet new people, meet friends, meet professors, get research done, and it's really a wonderful experience. So whenever, if they're going to be hosting a summer camp next time, highly recommend.
Thank you. And
All right.
I think one of the participants just recognized you from the picture. Good job.
Fourth from left, second row. Yep, right there. Congrats.
It was 2018.
Right. Okay. Well, thank you, Ms. Chen, for coming. The next guest speaker will be Mr. Chang Gan, and he is the president of the ACP Foundation. Let's welcome him up.
Thank you, Kevin. Can you hear me? Kevin?
Yep.
Okay, good. So, first I want to say it's really a wonderful program, very impressive. And as one of the sponsor, ACP Foundation is so proud to sponsor this AYSI great program. On behalf of ACP Foundation, it's my great honor to say congratulations to the success of the AYSI summer coding camp. Really good teamwork and achievement, great ideas from presentations, and good job. ACP Foundation is a non-profit American Chinese professional organization in the DFW area. Founded in 1993, ACP Foundation made a significant impact in the local communications. To cultivate the young generations, ACP would like to sponsor more and more great youth programs and activities like AYSI Summer Coding Camp. I also want to express my appreciation to all AYSI young instructors, program chairs for their dedication and hard work to make this program such a vast success. After this coding program, I can see all camp students not just learning technical skills, but also got the mindset of innovation. And that's important. And also this is why this program for. Thanks to Kevin, thanks to Kevin Mong and having me here, and thank you to all participants here, and congratulations to our winners. Thanks to everyone. Thanks, back to Kevin.
All right, thank you, Mr. Ken. ACP is an organization that does a lot of work in the community, so if you get a chance, go check them out. All right, so now just a little sort of like aside. We're also doing raffles. We're giving out a couple of $20 Amazon gift cards, which at this point has basically become cash. If you have Prime, it's instant cash. So go ahead and fill out this this QR code. Go to this QR code or go to that tiny URL. Fill out the document. Anyone on the call is welcome to join. And yeah, let us proceed to the awards. Alrighty, we're actually going to give you a couple of seconds to do this, as well as allowing the judges to finish up their deliberations.
And click to the next slide.
We're gonna go ahead and go forward with the awards for the Rising Stars Award, the 4th place, 3rd place. Those are already decided. So let's go ahead and continue to the Rising Stars Award. Now presenting this award will be Yinji. So let's welcome her up.
Hi guys. So I'm really honored to present our Rising Star Award. So the Rising Star Award is a very special award to recognize 4 students below the 6th grade who have demonstrated exceptional potential in our camp. So AYSI-SCI is a very fast-paced camp targeted mainly towards middle and high school students. So we really wanted to thank our younger students who have not only kept up with our very difficult and fast-paced curriculum, but have excelled and created really amazing projects that they have presented to judges. So we are really excited to see what you guys accomplish in the future. And without further ado, next slide, Kevin. Congratulations to Carl Hui, Oscar Lee, Hollis Lin, and Clement Wang. Congratulations.
Next, we're gonna do a raffle drawing. So to handle this, Derek will be helping us out.
Okay, so everyone's gotten their tickets in. First,
Yeah, whoever's on the sheet, we'll just roll with that.
yeah, the first winner for raffle for our amateur card is Julia Devar.
All right, yeah, so if you are the recipient of a raffle award, we're going to be emailing you with information. So let's Next up is the 4th award, and the individual who's presenting this, let's welcome them up.
So we have our 4th award here, and for the 4th award, you'll be receiving a trophy. So with the junior division, 4th award will be going to Project J11, Carbon Dioxide Reduction, Project J20, the Dog Dictionary, J21, COVID-19 Case Tracker and Comparison Calculator, J23, Grade Face ID, J33, Happiness Game, and finally J39, Edu Project. Congratulations to these Junior Division 4th Award winners. In the Senior Division, we have 6 4th Award winners. S2, Snap Cycle. S6, Deepfake Photoshop Image Detector using convolutional neural networks via deep learning. S10, Shield COVID. S24, Second View Alzheimer's Disease Recognition. S29, Low Maintenance Method of Detecting Mask Wearing in a Public Area via Machine Learning and Computer Vision. And finally, S31, Tracking Phone Usage to help users increase productivity. Congratulations to all our Senior Division Award winners.
Another raffle for Derek.
Okay, so the next winner of the raffle is Debbie Chang.
Yay! All right, congratulations. You now have $20 more in your Amazon gift card account. So let's move on to the 3rd award.
Sure. Okay, hi everybody. My name is Noah, and today I'm going to be presenting the 3rd award for our members. So in the junior division, we have 4 recipients of the 3rd award who will be receiving this very elegant looking green trophy. So first up, we have J4 and the book app, J6, Music Buddy, J10, Family Finder, and J28, Hydraulic Flume Simulation. And for the senior division, we have 4 3rd place awards as well. S26, an application for quick classification of American Sign Language via deep learning image recognition. Team S5, predicting house prices by linear regression. Team S4, Pocket Recycler, a convolutional neural network approach to recyclables classification. And finally, S25, classifying skin disease via artificial neural networks. Congratulations to all of our third place recipients.
Thanks, Noah. At this point, we're going to go with another round of raffles.
Okay, so our third raffle winner is Yvonne.
Can you say that again?
Yvonne Zhu.
Okay, wonderful. Congratulations. Another $20 Amazon gift card out. Derek, hopefully you're recording all these names so that we can contact them later. So at this moment, we are moving on to the second award winners. Now, our judges are still making their final deliberations. So if you bear with us a second, we're going to cover a little bit more of the additional content at the end to kind of, fill in the time. Another, one of the big things that I think is super, super important is to recognize all of the people that made this event possible. And there's no more important part to a camp. We need the people to execute everything, to plan everything. And so here before you, you see all of the major staff and faculty on the camp. You have all the way from the program director to the leads of each of the committees to teaching staff, all the way to guest speakers that we had for Introduction to AI and Dr. Ranganath from NYU for coronavirus-related applications. And then finally, we have our advisory board, which is able to oversee all the operations of the staff, and we're able to make sure that everything is on track. So again, a huge thank you to our staff and faculty. Now we're going to move on to our 2020-2021 AYSI plans. Alay will talk about this.
So moving forward to 2021 in our AYSI plans, we're looking at going back into our main goal of aiding students' initiatives and research. So we're a firm believer of students competing in the science fair process. So granted, again, this is granted that the science fair program continues, given all the COVID pandemic stuff. A lot of it is unsure, but given that everything continues, we're gonna move forward with our science fair program, and we're gonna have two different things. A science fair program, mainly meant for entry-level researchers, people who are just joining science fair, people who are joining the newer, like people who are more so in the junior division or early starting off in the senior division. This will include seminars and meetings on how to deal with science fair, how to present, how to execute your project, how to plan your project. If there were any members from last year's science fair program, it's similar to that, but of course we've evolved and changed our system so that we can give forth the best possible teaching to those people who are just joining the science fair program. And then we also have a new program here. It's called the research program. This is meant for more advanced science fair students who want to have one-on-one mentorship with students with past students who have gone to competitions like the Intel International Science and Engineering Fair, the Intel Science Talent Search, or have even gotten their research published or gone to conferences. It's for people who want to take their research to the next level and attempt to get one-on-one mentorship in order to kind of go from an entry-level science fair competitor to a much more advanced science fair competitor. That's what the research program is going to be for. In that case, you'll be working with an undergraduate, someone who's done science fair in the past and is now focused on research, as well as a professor who does research full-time and can tell you how to create papers and presentations, posters, and apply to conferences with much greater kind of with a much greater skill than the normal science fair program. We're gonna start around like announcing things around late August, and it would start around sometime in September, so that we want to get a jump in front of the main science fair season. The science fair season starts in around October with planning, and then the first fair will be around December or January, and then it can go all the way up until May at the International Science Fair. But we're going to be announcing our more detailed plans as time goes on. But for sure, 2020 and 2021 for AYSI will be a great year pushing forth students who are interested in science fair research, getting cool awards and going to cool places. Be on the lookout for any news regarding our program. All of you guys are great candidates for this because you've learned all of the computational skills necessary to create a great project. And over the past 4 weeks, you've already created a project. And a lot of these projects can be evolved, improved, and turned into a great science fair project. So as time goes on, we'll announce our different plans for the program, and you can, we'll let you know about the details of it, and you can feel free to join. We'll have some kind of an orientation or an open house meeting where people can join and get information about the program before joining. But be on the lookout for our really ambitious future plans.
Thanks, Elaine. And another thing that I just wanted to mention is that the immediate future of science fairs and just these kinds of activities are fairly in the air. But the one thing that you can count on is that our team is looking to bring whatever services are necessary in order to help you adapt to whatever situation it is. Whether it's COVID, this year, this camp was a perfect example of that. Adapting to the fact that you can't go anywhere for research, you can't go anywhere to learn anything, it's all going to be virtualized. So our team is going to send out more information. I would highly encourage a lot of you to look into that because science fair is just, it's an activity that really tests every part of you, your technical ability, your ability to communicate, dealing with people, because often dealing with people is harder than dealing with code because code listens to you and people don't. So there are so many different things that are important to keep in mind. And yeah, our team is going to bring that to you.
And yeah, like Kevin said, a lot of these competitions are most likely, at least in the first semester, going to be virtual. And for example, a few of us have had experience with the virtual fairs right at the end of the last season. So we're going to be changing up how you present and how you create projects, and we're going to maximize your ability to do well in those kind of fairs.
All right, so it looks like our judges have finished their deliberations. So just give us a brief moment to compile everything and we will be right back. Now, while our officers are compiling all of these results into the slides, I'd just like to take a moment to invite all of our judges to come say a couple words about, you know, their experiences and their thoughts on programming in general or the projects that you guys built. So judges, feel free to unmute yourself at any moment and say whatever you'd like.
Yeah, hey everyone. I just want to say it was absolutely phenomenal judging you guys and hearing you guys. I'm honestly so thoroughly impressed. I remember when I was, you know, at this time of age, and there was no way that I was doing things as complex as this. I mean, building apps and embedded systems and training all these novel neural network architectures. It's just, it's super crazy. So we definitely had a hard time judging and figuring things out. But yeah, I just think you guys have done amazing. I just seeing all you guys talk has been very inspiring for me as well. And you know, I hope you guys end up pursuing, whether it's this project or end up pursuing something else in the future. I know you guys will all go very, very far. So yeah, congratulations and good luck.
Thanks so much, David. And to all of the judges, David, Eric, Fatma, thank you for taking the time to come judge. We all know you're extremely busy people. Any other remarks?
The rankings are almost put up, but I'll let everyone when it's time.
Hi, Kevin. I'm just curious, do you have honorable mention?
Yes, honorable mentions are at the very end.
Along with some more raffle.
Sure. Derek, want to do another raffle drawing?
Okay, give me a sec. Okay, so our next raffle winner is Bill Ma.
Okay, great. Congratulations. Another $20 Amazon gift card out. So congratulations to all the current winners, all the current raffle winners, award winners. Just let me know, team, when we have completed filling in all of the blanks. All right, looks like our judges, all of our officers have completely filled everything out. So we're going to go ahead and refresh the page and announce our final winners.
Before we say anything, we want to say good job to all of the finalists who presented today. We were notified by the judges that the rankings were extremely close. So whatever happens, everybody's project and presentation was amazing.
Okay.
Thanks, Alay. So presenting the second awards will be Derek.
Yeah, so the second award, it includes outstanding projects from our preliminary round as well as some of the finalists. So you can move on here. For the junior division second award, each team will be receiving a cash prize of $100. And our second award winner is J8, Trace It, a COVID-19 contact tracing app. J16, Our Movies. J18, app that aids to detect plagiarism. J26, MediLinked. And J37, House Stability Detector. Congratulations to all of our junior division second place award winners. For senior division's second awards, they'll be receiving a cash prize of $200 for the team. Our first award winner is S1, Alert System for Reducing Occurrences of Car Accidents Related to Driver-Related Mistakes. S15, Arch AI. S18, Detecting Underage Alcohol Consumption in a Non-Intrusive Manner Using Deep Learning. S22, Fast Violence Detection Through Deep Learning.
Congratulations to all of the winners.
Yeah. So we have another raffle round before we announce our first place awards and grand prizes. So let me zoom in. Okay, so our fifth and final raffle winner is James Liu. So
Congrats, James. All right. So now we are getting into first award and grand awards.
The first awards represent the top project in each of the junior division and the senior division. And then later, right after this, Kevin will announce the Best of Fair Award, which is the best project that we saw out of all projects announced in our competition program. So we'll start with the junior division first award. The junior division first award is J24, the COVID-19 clinic app by Kara Sue and Ellen. It comes with a prize of $200 in the trophy, and yeah. The next is the senior division first award with a cash prize of $300. Team S7, the Soap Underwater Detection System, or SUDS, by Ethan Zhao, Aaron Liu, and Alan Zhao. Congratulations, guys.
All right. So now, presenting the Best in Show Grand Prize winner. This, as Alay talked about, was the best project that the judges selected over an arduous process of 3 days, 2 days of preliminary judging and 1 day of finals judging. Without further ado, the team awarded Best in Show Grand Prize winner of the 2020 AYSI-SCI Summer Coding Institute is S32, Endangered Species Classifier, for Evan Yu, Michael Zhang, and Alex Chong. Congratulations to all of the winners, not just the Best in Show Grand Prize winner, not just the first, second, third, fourth prize winners, but to everyone. It was incredible work, and Eric was talking to us earlier, so was David and Fatma. The rankings were extremely, extremely close. It was very hard to pick among these. So be proud of yourself, not just for the award that you won, but for everything you've learned about presenting your project, about building projects with new technical skills, about solving problems that are very relevant to our world. With that said, we also have some honorable mentions that we'd like to present. So presenting the honorable mentions will be Rachel.
As Kevin mentioned, congratulations to all of the winners. You guys have worked so hard, and now it's time to announce the honorable mentions. So if your project ID and title are listed, you're going to be receiving a certificate. So in the junior division, we have J7 and News J27, using MIT App Inventor to help students manage stress using problem-based coping. J5, Kids Adventure. J29, Obesity Solve. J22, Secure Messenger App. J38, Expired Products. J34, Dangerous Animal Classification Tool. J30, The Way of the Sensors. J12, Tax Estimator. J32, Gardening App. J15, Learning App. J35, Improving and Maintaining Mental Health Through Music. J36, the SOS Emergency App. J19, Fade. J17, Bookfinder. And J9, Nielsen Jester. Congrats, Joe. And now for the Senior Division Honorable Mentions. S16, Heart Health App. S27, Detecting Phishing Emails, SMS Text with Machine Learning. S11, Neural Network-Based Speech-to-Text System with Identification of Stuttering. S3, Identification of Fake News. S28, Food Identification App. S9, Distinguishing Poison Ivy from Similar Three-Leafed Plants Through Deep Learning Image Classification. S8, FaceSpace, a free accessible program for facial detection. And finally, S21, COVID-19 prediction. Congratulations to all of our honorable mentions and all of our winners.
Thank you, everyone. This was, of course, all of the judges have come to us and have said how incredible you guys have all done. The incredible projects, the homework that you've completed, all of the things that you've learned. We've hoped that you took something away from this. Again, I just wanted to thank our staff and faculty for everything that they've done to putting together this camp for over 200 of you guys across North America. So if you are on this call or you are somewhere else watching this recording later, just want to know, thank you from the bottom of our heart, from all of the AYSI officers. You are what made this camp possible, and it would have been nothing without you. So with that said, we leave you with a nice collage of all of the students who turned in their headshots. This represents everything you've done. This is the community that we've built, the skills that we've learned, and the things that we will take from this camp as alumni. So feel free to screenshot, share, whatever you might do. Just know that we're extremely proud of what you've done, and we hope that you enjoyed it. So finally, it is our time to say goodbye. And by no means is this a complete goodbye. You know, if you're going to join us for the school year for our Science Fair Mentorship Program, or if we host programs like this in the future, we'd love for you to join. We're just saying goodbye for now. As the little Winnie the Pooh little quote says, I think all of us are very lucky to have something that makes it so hard to say goodbye. So with that said, have a great rest of your summer. Good luck, stay safe. And our officers and lecturers are always going to be here. Feel free to message us if you ever need anything or anything like that. So with that said, have a great rest of your day, everyone. Goodbye.
Loved having you.
I am amazing.
I don't doubt that.
Thanks. Thanks for having this here.
No problem. Thanks.
Thank you.
Thank you so much.
Thanks, everyone.
Thank you. Amazing job.
Thanks all. Love you, Mevin.
All right, bye, people.
Okay, thank you and bye.
Thank you. All right, officers, I'm just gonna end the meeting here. We'll talk later as for procedures that we need to take to wrap things up. But basically that includes writing up a report of sorts,
And then just sending
distributing all of these awards somehow, and yeah, just tying up loose ends.
Yeah,
Not in
and
a not sketchy
t-shirts.
way.
T-shirts too, yeah.
T-shirts.
Yeah, t-shirts. Oh, if
sure.
you didn't hear, we got like a $400 discount on our t-shirts because they messed our order up and it's not coming until next week.